Welcome again to Formula 1 Maths and to pass exam questions 004 for the higher tier. We've got 3 questions to answer. Question 1. Write 0.523 recurring as a fraction in its simplest form. First of all, I want you to note that the 5 here is not recurring. It is the 2 and 3 with a dot on them that is recurring. So we start solving this question by saying let x equal to 0.523 recurring. This implies that x is equals to 0.523232323 and so on. Then we go and multiply the fraction by multiples of 10. Now let me state here that it's not all multiplication by multiples of 10 that works. So we'll see that very soon. So let's start multiplying by 10. So if I multiply by 10, I'll get 10x on the left-hand side, and then 5.23232323 and so on the right-hand side, like this. Now let's try multiplying by 100. So if I multiply by 100, I'm going to get 100x on the left-hand side, and I'll get 52.323232 recurring. As you can see, for the case of 10x, the recurring decimal is isolated behind the decimal point, as you can see here. So 2323 is isolated behind the decimal point. For the case of 100, we have 323232 instead of 2323 recurring. And so this is not good. So we go on and multiply by 1,000. So if I multiply by 1,000, 1000x, I'll get 523.232323. And now you can see that the recurring decimal is now isolated behind the decimal point in this case. So on this occasion, 100 times x does not work, but 10x and 1000x works. So we're going to use these two to solve our equation. So how do we do that? We will go and subtract 10x from 1000x, like this. When I do my subtraction, I will get 990 on the left-hand side, and then 518 on the right-hand side. Then I go to solve for x by taking 990 to the other side. It goes to divide, and now all I'm left to do is to simplify. These two numbers are big for a non-calculator paper, so I'm going to show you an easy way of dividing this or simplifying this fraction. So 518 over 990. I can see from here that the last digit here is 8 and the last digit here is 0. So that means both numerator and denominator are divisible by 2. So I'm going to divide both numerator and denominator by 2. So if I do that, I'll take it step by step. 2 goes into 5, 2, remainder 1, I put a 1 here, and now I have 11. Now 2 goes into 11, 5, remainder 1, I put a 1 here, and now I've got 18. 2 goes into 18, 9 times, and I'm done with the numerator. I do the same thing with the denominator. 2 goes into 9, 4 times, remainder 1, now I have 19 here. 2 goes into 19, 9 times, remainder 1, put it here, and now I have 10 here. And 2 goes into 10, 5. So I'm left with 259 over 495, and that is the simplest form. So our answer is 259 over 495. Question 2. The diagram shows a sketch of a vertical cross-section through the center of a bowl. The curve has equation y equal to x squared over 12 minus 5x, where x and y are both measured in centimeters. Find the depth of the bowl. So we start by rewriting this equation in the factorized form, like this. Now looking at this graph, on the x-axis, we have y equals to 0. But we need to find the roots of this curve here, or the roots of this equation. And the roots occur at this point and at that point. And to find that, we find where this curve intersects the x-axis. And for the x-axis, the equation is y equals to 0. So we equate this here to 0, like this. Then we solve. So when we solve this, we have two solutions. One of them will be x equals to 0, or the other one will be x over 12 minus 5 equals to 0. We have got one of the solutions here, x equals to 0. So that means that x here is 0. For the other one, I need to solve x. If I solve it, x, I'll get 60. And that means this here is 60. Now, by symmetry, the midpoint of this curve here occurs somewhere there, and that will occur where x equals to 30 by symmetry. And that's where the depth of the bowl can be measured. So, for the depth of the bowl, x must be equal to 30. That means that I need to substitute 30 into the equation here to get the value of y at this point. So when x is 30, y will be equal to 30 squared over 12 minus 5 times 30. This is a big calculation to do for a non-calculator question. So let me show you an easy way of doing this. So I'm going to write this as y equals to 30 times 30 over 12 minus 5 times 30. Then I can do some reduction. 6 goes here 2, 6 goes there 5. And then 2 goes here 1, and 2 goes there 15. So I'm left with y equals to 5 times 15 minus 5 times 30. I can now see that 5 is common, so I can bring 5 out of the brackets. And I'll be left with 15 here and 30 over here. So I can simplify this to 5 times minus 15, and I'll get minus 75. And the negative sign means that it's in the opposite direction here. So going up is positive, coming down is negative. So the depth is the same as this length here, minus 75, but the negative sign just tells us the direction. And so our depth is 75 centimeters. Question 3. A, B, and D are points on the circumference of a circle. Center O. ADC is a tangent to the circle. Angle BDC is 65. This angle BDC 65, so this is 65 degrees. Find the size of angle AOB. Angle AOB is this one here. You must give a reason for each stage of your working. There are a number of ways of finding this angle. I'm going to show you 3 ways of finding the same angle. And all these three methods are acceptable in the exam. So let's get started. Method 1. ADC is 90. ADC is 90. And the reason you give for that is diameter and tangent are perpendicular. So the diameter of a circle and a tangent to it will always meet at 90 degrees. So now we can go and calculate this angle here easily. Because this is 90, the whole of that is 90, and this is 65. This means this is 25 degrees. And this is by subtraction. Now, one of the second theorems states that an angle subtended at the center by a chord or arc is twice the angle subtended at the circumference by the same arc or chord. So we are looking at this arc here, or this chord. This chord subtends an angle AOB at the center. And the same arc subtends an angle ADB, which is 25 at the circumference. So it means that angle AOB is equal to 2 times angle ODB. We know the value of angle ODB, that's 25, and that means angle AOB is 50 degrees. So that's method 1. Method 2, angle OAB is 65, angle OAB. So this angle is 65. And the reason you give for that is alternate segment theorem. Alternate segment theorem simply states that when you have an angle here, which is in this segment here, this will be equal to the opposite angle in the triangle in the alternate segment. Now, this means that angle ABO, this one, is also 65. And why is this 65? Base angles of an isosceles triangle are equal. So what I'm saying is this angle here is an isosceles triangle because OA is a radius and OB is a radius. So same length, that makes this triangle an isosceles triangle. So these base angles are equal. Now I know that in a triangle, all the angles add up to 180. So all I can do to get this one here is to add these two and take it away from 180, and that's what I'm doing here. So if I do that, I'm going to get 50, and this is the same as the angle we got before. So that's method 2. Now method 3. Angle ADC is equal to 90, as we saw in method 1. Angle ODB is 25, again from method 1. But this time, we can also say that this angle here is 25. And the reason, again, is base angles of an isosceles triangle are equal. So, why is this an isosceles triangle? OD is the radius and OB is the radius. That makes this triangle an isosceles triangle. So now that I know that this is 25 and this is 25, I can add these two, take it from 180 to get this angle here, angle BOD. So angle BOD will be 130. I also know that angle BOD and angle AOD are on a straight line. And the angles on the straight line add up to 180. That means I can take this angle here, which is 130, from 180 to get angle AOB. So if I do that, I'll get 50, and that is the last method. This is the end for this past exam set of questions. Thank you for watching again, and I'll see you in the next video.